Copyright 2014 to 2022 George Zadi. Copyright 2011 to 2022 Alexander Wolf. Copyright 2006 to 2013 Matthew Gates. Copyright 2013 to 2014 Barry Gerdes, 2014. Stellarium.org. Permission is granted to copy, distribute and/or modify this document under the terms of the GNU Free Documentation License, version 1.3 or any later version published by the Free Software Foundation, with no invariant sections, no front cover texts, and no back cover texts. A copy of the license is included in the Appendix G entitled GNU Free Documentation License. All trademarks, third-party brands, product names, trade names, corporate names, and company names mentioned may be trademarks of their respective owners or registered trademarks of other companies and are used for purposes of explanation and to the reader's benefit, without implying a violation of copyright law. Version 1.1-1, October 31, 2022. 1. Introduction. Stellarium is a software project that allows people to use their home computer as a virtual planetarium. It calculates the positions of the sun and moon, planets and stars, and draws how the sky would look to an observer depending on their location and the time. It can also draw the constellations and simulate astronomical phenomena such as meteor showers or comets, and solar or lunar eclipses. Stellarium may be used as an educational tool for teaching about the night sky, as an observational aid for amateur astronomers wishing to plan a night's observing or even drive their telescopes to observing targets, or simply as a curiosity. It's fun because of the high quality of the graphics that Stellarium produces. It is used in some real planetarium projector products and museum projection setups. Some amateur astronomy groups use it to create sky maps for describing regions of the sky in articles for newsletters and magazines, and the exchangeable sky cultures feature invites its use in the field of cultural astronomy research and outreach. Stellarium is under continuous development, and by the time you read this guide, a newer version may have been released with even more features than those documented here. Check for updates to Stellarium at the Stellarium website. 1. If you have questions and/or comments about this guide, or about Stellarium itself, visit the Stellarium site at GitHub 2 or our Google Groups Forum 3. Since its inception, Stellarium's version number had started with 0 to indicate work in progress. The numbers after that have followed a year-release convention with approximately seasonal releases since 2018. For example, 0.18.2 was the third release in 2018, which appeared around autumn equinox, after 0.18.0 and 0.18.1. A software version number of 1.0 signifies a milestone of some sort, like completion of a particular original feature set, usability, or stability. With the completion of the original accuracy issues in 2021, we felt it was time to finally change version number to 1. However, a major technical update in the underlying Qt framework also forced some technical changes upon us to ensure Stellarium will remain working in the later 2020s, and therefore we decided to base the 1** series on the new version of Qt. Qt 6 does not support old hardware, particularly 32-bit systems will not be able to run 1** versions. Therefore, we are going to keep both series alive for those with older hardware. Thanks to only minor differences in the underlying frameworks, both series should retain feature equivalence. The only notable difference for now lies in the scripting functionality. See Chapter 17. Our internal version numbers therefore indicate which version of Qt is used. Series 0** will continue to be based on Qt5, and Series 1 * will be based on Qt6. 1.3 Acknowledgements. Stellarium has been kindly supported by ESA in their Summer of Code in Space initiatives, which so far has resulted in better planetary rendering, 2012, the Meteor Showers plugin, 2013. The web-based remote control and an alternative solution for planetary positions based on the DE430/DE431 ephemeris, 2015, the Remote Sync plugin and OBJ models, 2016, and the Planet Nomenclature labels, 2017. Some of George's work is supported by the Ludwig Boltzmann Institute for Archaeological Prospection and Virtual Archaeology, Vienna, Austria. 6 Chapter 1. Introduction. 1.4 Scientific use. Stellarium has gained wide popularity in the research areas of cultural astronomy. Please note limitations of Stellarium mentioned in Appendix F. If you use Stellarium in scientific work, please cite our recent paper, Zadi, Hoffman, et al., 2021, or those mentioned in the respective feature descriptions. 1.5 About this user guide. This guide is based on the user guide written by Matthew Gates for version 0.10 around 2008. The guide was then ported to the Stellarium wiki and continuously updated by Barry Gerdes and Alexander Wolf up to version 0.12. Unfortunately, some new features were not properly documented in the wiki, and generally, without Barry the wiki started to fall out of sync with the actual program. In late 2015 we, Alexander and George, started porting the texts back to LaTeX and updated and added information where necessary, or wrote new chapters for the features which were introduced in the last years. We feel that a single book is the better format for offline reading. The PDF version of this guide has a clickable table of contents and clickable hyperlinks. These new editions of the guide, since version 0.15, do not contain notes about using earlier versions than 0.13 or using very outdated hardware. Some references to previous versions may still be made for completeness, but if you are using earlier versions of Stellarium for particular reasons, please use the older guides. 2. Getting started. 2.1 System requirements. Stellarium has been seen to run on most systems where Qt5 is available, from tiny ARM computers like the Raspberry Pi 2/3/4 or Odroid C1 to big museum installations with multiple projectors and planetaria with fisheye projectors. The most important hardware requirement is a contemporary graphics subsystem. 2.1.1 Minimum. Linux/Unix, Windows 7 and later, macOS 10.15 and later 1. 3D graphics capabilities which support OpenGL 3.0, 2008 GeForce 8XXX and later, ATI/AMD. Radeon HD, 2XXX and later, Intel HD graphics, Core i2 XXX and later, or OpenGL ES 2.0. Example ARM SBCs like Raspberry Pi 2/3/4. On Windows, some older cards may be supported via Angle when they support DirectX 9. Screen resolution 10247682. 512 MB RAM. 250 MB free on disk. Keyboard. 2.1.2 recommended. Linux/Unix, Windows 10 and later, macOS 11.0 and later. 1 Windows 10 and macOS 11.0 is minimal for Qt6-based Stellarium. 2 On Linux, an 800,600 screen can still be used by scaling the desktop e.g. to 12000900. Render output HDMI-1, scale 1.5x 1.5. To reset after running Stellarium, run Zrander output HDMI-1 scale 1:1. 8 Chapter 2. Getting started. 3D graphics card which supports OpenGL 3.3 or higher. Full HD 19201080 or 19201200 or larger screen. 0.3. 1 GB RAM or more. 1.5 GB free on disk, about 3 GB extra required for the optional DE430/DE431 files. Keyboard and mouse or equivalent device, e.g. touchpad. A dark room for realistic rendering, details like the Milky Way, zodiacal light or star. Twinkling can't be seen in a bright room. 2.2 Downloading. Download the correct package for your operating system directly from the main page. https://stellarium.org. An archive of all available versions is available at our GitHub page. https://github.com/stellarium/releases. 2.3 Installation. 2.3.1 Windows. 1. Double-click on the installer file you downloaded. Stellarium 1.1 Win64.exe for 64-bit Windows 7 and later. Stellarium 1.1 Win32.exe for 32-bit Windows 7 and later. 2. Follow the on-screen instructions. 2.3.2 macOS. 1. Locate the downloaded Stellarium file in Finder. Stellarium will be automatic unpack. From archive by operating system after downloading. 2. Drag Stellarium to the applications folder. 2.3.3 Linux. Check if your distribution has a package for Stellarium already. If so, you're probably best off using it. If not, you can download and build the source. For Ubuntu Linux, we provide a package repository with the latest stable releases. Open a terminal and type sudo apt repository ppa stellarium/stellarium releases. Sudo apt get update. Sudo apt get install Stellarium. You can also download and run universal binary packages for Linux systems, FLAT4 or Snap5. Raspberry Pi 2/3/4. These tiny ARM-based computers are very popular for small and energy-efficient applications, like controlling push-to-Dobsonians. Stellarium requires Mesa 17 Relator, available in the current Raspbian OS. To set up a Raspberry Pi 2 or 3 with Raspbian Buster for use with Stellarium, activate the OpenGL driver in raspi-config. The latest Raspberry Pi 4 comes with this driver by default, and can even drive 2 high DPI screens. You must build Stellarium from sources. Please follow instructions from the Wiki 6. 3 high DPI screens may work, but show occasional platform-dependent issues. For https://flathub.org/apps/details/org.stellarium. 5 https://snapcraft.io/Stellarium daily. 6 https://github.com/stellarium/wiki/raspberry pi. 2.4 Running Stellarium 9. For Ubuntu 16.04 LTS, follow instructions 7. Note that as of December 2019 the 3D planets do not work on Raspberry Pi 2/3 and DSS or HIP surveys seem to cause issues after a while. 2.4 Running Stellarium. 2.4.1 Windows. The Stellarium installer creates a whole list of items in the Start menu under the Program/Stellarium section. The list evolves over time. Not all entries listed here may be installed on your system. Select one of these to run Stellarium. Stellarium OpenGL version. This is the most efficient for modern PCs and should be used when you have installed appropriate OpenGL drivers. Note that some graphics cards are blacklisted by Qt to immediately run via Angle, Direct 3D. You cannot force OpenGL in this case. This should not bother you. Stellarium Angle Mode uses Direct 3D translation of the OpenGL rendering via Angle. Library forces Direct 3D version 9.8. Stellarium Angle Warp Mode uses DirectX 3D 11 software rendering via Angle library. This should work on any PC without dedicated graphics card. 9. Stellarium Mesa Mode uses software rendering via Mesa library. This should work on any PC without dedicated graphics card. Stellarium 200%. On some systems with 4K screens, Stellarium appears too small. This link forces an upscaling. If for some reason Stellarium's dialogues and buttons appear too large, and you want to scale them down, edit the link and change the scaling parameter. On startup, a diagnostic check is performed to test whether the graphics hardware is capable of running. If all is fine, you will see nothing of it. Else you may see an error panel informing you that your computer is not capable of running Stellarium, no OpenGL 2 found, or a warning that there is only OpenGL 2.1 support. The latter means you will be able to see some graphics, but depending on the type of issue you will have some bad graphics. For example, on an Intel GMA 4500 there is only a minor issue in night mode, while on other systems we had reports of missing planets or even crashes as soon as a planet comes into view. If you see this, try running in Direct 3D 9 or Mesa mode, or upgrade your system. The warning, once ignored, will not show again. When you have found a mode that works on your system, you can delete the other links. 2.4.2 OS X. Double-click on the Stellarium application.